In the grand tapestry of human endeavor, efficiency stands out as a beacon of progress. From the earliest farmers optimizing crop yields to modern engineers designing super-efficient vehicles, the pursuit of efficiency has been a constant throughout history. But what is efficiency really? At its core, it is the art of minimizing waste while maximizing output. Efficiency is not just about working harder, it is about working smarter. In the late 19th century, as the Industrial Revolution was in full swing, a new approach to efficiency emerged: scientific management. This revolutionary concept, pioneered by Frederick Winslow sought to apply the principles of science and engineering to the management of work. Frederick Winslow was not a captain of industry, nor a titan of finance. He was an engineer, a man of science and precision, who saw in the chaos of the factory floor an opportunity for order and optimization. Born in 1856 to a wealthy Philadelphia family, Taylor seemed destined for a life of privilege. However, he chose a different path, one that would lead him to the heart of industrial America. After abandoning his plans to attend Harvard University, Taylor opted for an apprenticeship at a Philadelphia pump manufacturing company. It was here, amidst the whirring machinery and the sweat of laborers, that Taylor's fascination with efficiency took root. He meticulously studied work processes, timing workers with a stopwatch and analyzing their movements. Taylor's groundbreaking work, culminating in his landmark book, The Principles of Scientific Management, published in 1911, would earn him the title of Father of Scientific Management. At the heart of Taylor's scientific management philosophy lay a simple yet powerful idea. To improve efficiency, you must first understand how work is actually done. Two key pillars of this methodology were time studies and motion studies. Time studies involved carefully timing each step of a work process using a stopwatch. By breaking down a task into its constituent elements and measuring the time taken for each element, Taylor aimed to identify and eliminate unnecessary movements and delays. Motion studies focused on analyzing the movements involved in performing a task. Taylor believed that by carefully studying the movements of skilled workers, he could identify the most efficient way to perform a task. Together, time and motion studies formed the empirical foundation of Taylor's scientific management. While time and motion studies provided the data-driven foundation for scientific management, two additional pillars were essential for its successful implementation: standardization and scientific selection. Standardization meant establishing clear, consistent procedures for every task. This involved developing detailed work instructions, specifying the tools and materials to be used, and outlining the exact steps to be followed. Scientific selection involved applying scientific principles to the process of selecting and training workers. Taylor believed that workers should be carefully matched to jobs based on their skills, abilities, and aptitude. This meant using objective measures to identify the best person for each job. By combining standardization and scientific selection, Taylor aimed to create a workplace where every worker was equipped with the skills and knowledge to perform their jobs efficiently and effectively. Section 5. Task specialization, a cornerstone of efficiency. One of the key principles that emerged from Taylor's work was the concept of task specialization. This involved breaking down complex jobs into smaller, more manageable tasks and assigning each task to a specific worker. By focusing on a single, repetitive task, workers could become highly proficient in their assigned area. This mastery of a single task led to increased speed, accuracy, and overall productivity. Moreover, task specialization allowed for the development of specialized tools and equipment, further enhancing efficiency. From fast food restaurants to software development teams, the concept of breaking down complex tasks into smaller, more manageable units has proven to be a powerful tool for improving efficiency. However, it is crucial to balance the efficiency gains of task specialization with the needs and well-being of workers. Section 6. Incentives fueling productivity. While standardizing work processes and optimizing task allocation were crucial to Taylor's vision of scientific management, he also recognized the importance of motivation. He believed that to truly maximize productivity, workers needed to be incentivized to perform at their best. Taylor proposed a simple yet powerful idea. Workers should be paid based on their output, not their time. This system, known as piece rate pay, rewarded workers who exceeded the established production quotas, providing a direct financial incentive to work efficiently. Taylor also recognized the importance of other forms of motivation, advocating for creating a more positive work environment and recognizing exceptional performance. Some argue that it can lead to a focus on quantity over quality, as workers prioritize output over other important factors. Despite these criticisms, the use of incentives remains a widespread and influential legacy of scientific management. Section 7. Scientific management in action, from factories to hospitals. While Frederick Winslow Taylor's ideas were initially applied in industrial settings, the principles of scientific management quickly spread to other sectors, demonstrating their versatility and broad applicability. In manufacturing, Taylor's ideas revolutionized production processes. The assembly line, a classic example of scientific management in action, broke down complex tasks into smaller, specialized steps, dramatically increasing efficiency. Car manufacturer Henry Ford, inspired by Taylor's principles, famously implemented assembly lines in his factories, making automobiles more affordable and accessible to the masses. The impact of scientific management extended beyond the factory floor, reaching into the realm of healthcare. Hospitals began to apply Taylor's principles to streamline patient care, reduce wait times, and improve overall efficiency. The enduring legacy of scientific management is a testament to the power of efficiency. Section 8. The human factor impact on workers. While scientific management undoubtedly led to significant gains in efficiency and productivity, its impact on workers was more nuanced and complex. On the one hand, scientific management often resulted in higher wages for workers. As productivity increased, companies were able to offer better pay and benefits, improving the standard of living for many. Additionally, the emphasis on training and skill development provided workers with opportunities for advancement and higher earning potential. However, the implementation of scientific management also led to concerns about worker alienation and de-skilling. The repetitive nature of specialized tasks, coupled with the strict adherence to standardized procedures, could lead to monotony and a sense of detachment from the final product. The legacy of scientific management on workers, therefore, remains a subject of debate. Section 9. Controversies and Criticisms. Despite its undeniable impact on the world of work, scientific management has not been without its share of controversies and criticisms. One of the most persistent criticisms leveled against scientific management is that it dehumanizes workers, reducing them to mere extensions of machines. By breaking down tasks into their smallest components and dictating every movement, critics argued that Taylor's system stripped work of its inherent meaning and satisfaction. Another major point of contention was the potential for exploitation. Critics argued that the emphasis on output and efficiency could be used to justify speed-ups, wage cuts, and unsafe working conditions. Furthermore, some argued that scientific management concentrated too much power in the hands of managers, leaving workers with little autonomy or control over their work. These criticisms, while valid, should not overshadow the positive aspects of scientific management. Section 10. The enduring legacy of scientific management. Despite the controversies and criticisms, the legacy of scientific management continues to shape the way we work today. One of the most enduring legacies of scientific management is the emphasis on data-driven decision-making. Taylor's meticulous approach to measuring and analyzing work processes paved the way for the use of data analytics in modern management. Moreover, the principles of standardization and process improvement, central to Taylor's philosophy, remain essential tools for achieving efficiency. While the rigid, top-down approach to management advocated by Taylor has largely fallen out of favor, his emphasis on training and development continues to resonate. In conclusion, while scientific management may have its flaws, Its enduring legacy lies in its contribution to the development of modern management practices. As we navigate the complexities of the 21st century workplace, we can learn from both the successes and failures of scientific management, striving to create organizations that are both efficient and humane.